Hi guys, we're looking at absolute value functions and graphs again today. That's section 2.6. This is day 2, and we're going to look at more examples. And when we look at these, I'm going to show you a way to use this general form to just make it a little easier and maybe avoid a little frustration in choosing the x values. In the homework, you may have at times started choosing x values and found that um, you were not finding the vertex. So all your points perhaps looked like this. You're plotting points and they just keep going, and you say, well, wait a second. And then you start plotting some this way, and at some point you give up. Maybe you say, there's no vertex ever. Of course, you give up just too soon, because the very next one would have gone something like this, and you'd say, now everything's fine. So it could just be a little time consuming and frustrating. So we can use this general form to help us choose points that will be very convenient. And let's see how to do that with this first one. So recall the general form looks like this, and you look at the number that's outside the absolute value bars that's multiplied by the absolute value. That's going to be the slope. And you look at what's subtracted in this, and we call it h, but whatever's subtracted from x inside the bars, that's the x coordinate of the vertex. And then whatever's added outside the bars, that's the y coordinate of the vertex. And we can, we looked at using this general form to plot the graph, but we're just going to use the general form in these examples to help us find what x values to use. And this is a pretty convenient technique. So look at this first one, and we're just going to find the x coordinate of the vertex by looking at this using the general form. And we see the x coordinate, that's h, right? Okay. It is whatever subtracted from x inside the bars. So what is subtracted from x in there? Well, 2. So we will use 2 as one of our points because we want to use that vertex, right? But we'll use a couple points that are less than 2 and a couple points that are greater. So we'll put the 2 right here. Don't be confused by the negative sign. You might think, well, the x coordinate of the vertex is -2. Well, it's not, because the negative sign is here in the general form, and we want what is following the negative sign, right? What is subtracted from x. So that's 2. And then we'll use just an x value 1 less than 2, and then 1 less than that. Okay, and then we'll use one that's 1 greater than 2, and then 1 greater than that. We'll use those for our x coordinates, and this should work really well because we'll have the vertex and we'll have 2 points on either side. So plug in 0 for x. 0 minus 2 is -2, and the absolute value of that is 2. But then we take the negative of that. That's -2, and then plus 1 is -1. Okay, so we'll use 1 now. So 1 minus 2 is -1, and the absolute value, that's 1. But then we take the negative of that, which is -1, plus 1 is 0. Okay, we'll put in 2. 2 minus 2 is 0, and the absolute value, that's 0. And then we take negative of 0, it's still 0, plus 1 makes 1. We'll put in a 3. 3 minus 2 is 1. The absolute value, that's 1. Take the negative of that. It's -1 plus 1 is 0. And then put in 4. 4 minus 2 is 2. Absolute value of that's 2. And we take the negative of that, so that's -2 plus 1 is -1. So this looks like it's pretty good. See, our y values go -1, then 0, then 1, and then they go back 0, -1. So it looks like we've got something that's going to work to look like a nice absolute value function. So let's plot these. 0, -1 is right here. 1, 0 is right here. Then 2, 1. And then 3, 0 is right here. This one opens downward because of this negative sign out front. Then 4, -1 right here. Okay, and now we can connect that. Something like that. And that's our graph of this absolute value function. Okay, so let's look at another one. This one has a 3 out front, we notice. Okay, that's going to be the slope, so you might expect this to be kind of steep. Okay, so let's take a look. We'll again find the x-coordinate of our vertex, and that's what's subtracted inside here. And let's see, I just noticed something I want to fix before I go on. Is down here, we want this to actually be a different function here. Oh, I need to. Oh, sorry about this, guys. Just take a second. Fix this. Okay, so what I wanted to use for this example well, we better go with black though. Okay, now we've got it. So now our last example, I wanted this 1/3 here instead of 3 to see what the difference, how it looks. So that's what we've got. So okay, back to this one. Sorry about that. So we look at what's subtracted from x, and it's 1 that's subtracted. So that's going to be the x-coordinate of our vertex. We're going to put it right here. And then we'll also go 0 and -1. So we'll take points to the left of the 1 on the x-axis, 0, -1. Then we'll go to the right of 1 and use 2 and 3. Okay? So we put in -1, and I won't go through these. I'll go through, do it a little bit more quickly this time. We put in -1, and in the bars is going to be -2, and the absolute value of that is 2, and 3 times that is 6. Okay, 0 is a pretty easy one. It's -1 inside the bars, and that absolute value symbols make it +1 times 3 is 3. Okay, now we use 1. So 1 minus 1 is 0 when we put 1 in for x. So absolute value, that's 0. 3 times 0 is 0. Okay, and then when we put in 2, 2 minus 1 is 1, and so absolute value, that's 1 times 3 is 3. Put in 3, then inside here you get 2, and the absolute value is 2, and 3 times that is 6. Okay? So let's plot that. We have negative 1, 6 is, I think we need to actually, we'll just eyeball this. 1, 2, 3, 4, 5, 6 is about here, right? So negative 1, 6, about there. And then can draw that better than that. 0, 3 looks like that. Then 1, 0 is right here. Then 2, 3 is here. 3, 6 is here. Okay, and boy, that's ugly. Drawing the graph. Okay, so I will mention the slope. The slope is 3, and so one side of our absolute value function will have the slope of 3, which we could see is rise over run 1, 2, 3, and over 1, right? Slope equals, for this one, I'll just write it in here, 3, which we can write as 3 over 1. And so that's the rise over the run. Okay. Up 3 over 1. Now you always have the other side will be the negative of that. So we use negative 3 as the slope. And so we go up 3, 1, 2, 3, and then over negative 1. And then that's the slope of the other side. Okay, well, let's look at one more example. And we're going to compare these two because this one is exactly the same except for the slope, the number outside, the multiplier you might call it, that you multiply this number times that absolute value. This time it's 1/3 instead of 3. Okay, so we'll see how that works and what difference we get because of that. So our vertex is the same because inside we still have minus 1. So the thing subtracted from x is 1. So we'll use 1, and then we'll use 0 and negative 1 going to the left. And then on the other side of 1, we'll use 2 and 3. Okay, so let's see what we get this time. When we put in the negative 1, inside's a negative 2, but absolute value, that's 2. Take 1/3 of 2. And because the third, this 1/3 out here. So 1/3 times 2 is 2/3. So you put in negative 1, your value is 2/3. Put in 0, inside 0 minus 1, absolute value, that's positive 1 times 1/3. So that's 1/3. Okay, and then when we put in 1, we just get 0 inside, and 1/3 times that is still 0. Then we put in 2, 2 minus 1 is 1. Absolute value is 1. And take 1/3 of that. And we put in 3, we get 3 minus 1, that's 2. So you have that 2 showing up again. 1/3 times 2 is 2/3. Okay, so let's graph this. Negative 1, 2/3. So that's only about up to here, not all the way up to the mark, right? 2/3. 0 is just 1/3, which is about right there. And then 1 is 0. 2 is 1/3, just 1/3. so not very far. And then 3 is 2/3. Something like, yeah, that's a little too high. Okay, so that's that one. So we're going to compare those two graphs. Let's move this a little bit. Okay, and so remember, didn't quite get the equation in there. So let's see if we can make this a little bit smaller. Get them both. Okay, that's better. So when our slope was 3, when there was a multiplier of 3 out here, it made it more steep. The slope of this is 3. This time the slope is only 1/3. The rise over the run is just 1/3 because that's what we have here. So when you go up 1, you go over 3. And we could use this point, the vertex, and we go up 1 and over 3, it would be over here. That's a point we didn't even use, right? Yeah, up 1 over 3 would give us this point right here. So that's the slope. It's just 1/3, not nearly as steep. And again, the negative slope, the negative of that slope gives us the slope of the other side. So this other side has a slope of negative 1/3. Okay, so that's all the examples we wanted to look at today. Hopefully this will help you pick your x values a little easier, and hopefully this gives you more familiarity with these absolute value functions. So I'll see you later.